Okay, hi everyone. Welcome to droidCon Online Multiplatform series. And my name is Rémon Helmond, and I'm going to talk about Painless Flutter embedding in your existing app. A bit about myself. I'm from the Netherlands. I am a mobile app developer at Philips Hue, and I work with Flutter since 2018. Within Philips Hue, we launched two apps that are built natively or from scratch in Flutter. Those are the Philips Hue Bluetooth app and the Philips Hue Sync app. Furthermore, I am maintainer of the Flutter Reactive BLE library, which is a library that maintains multiple Bluetooth connections in Flutter. I'm a sports fanatic and I'm Stand 3 certified, which means I know my stuff about wines. I'm really looking forward to connect to you, so feel free to reach out on me on either Twitter or LinkedIn. Yeah, so let's get started. A bit about Flutter. Well, everybody did hear about it, but just for completeness, Flutter is Google's UI toolkit on which you can build multiple natively compiled applications from a single code base. If you just want to start with Flutter, I really urge you to check out their website. They have really great resources and also great tutorials. The website is below. A bit about the technical overview of Flutter, because that gives also a good overview of how the embedding actually works. So first of all, we have the framework layer, which consists of the widgets, where you can define your animations, and everything in there is written in the Dart programming language. And actually, Dart is a language that is introduced by Google, and as Flutter as well. The next part is the engine, which is built in C and C++. And what it is doing for us is actually making sure that the frames that you created in Flutter are properly scheduled in the correct sequence, and also that the data is that is sent from Flutter towards the platform is actually arriving well. And that brings me also to the next part, because that's the embedder. As you can probably imagine, is that each platform has its own threading mechanism and also a different way of rendering things. So that's why that each platform has its own Flutter embedder for that. Also, check out the link that I provided below. That will give you also a bit more background information on it. Now let's get started where we all come from, the app-to-app approach. Actually, of course, what I already mentioned, the two apps that I started with on Flutter, they were greenfield projects, which is quite a luxury because we could start with Flutter from scratch. But of course, we all have legacy apps, and if we want to get started with Flutter, then without the app-to-app approach, we need to choose to really rewrite everything, and that's something we ideally wouldn't like to do. So because of that, they introduced this approach, and what it's actually doing is you can create a Flutter module and you can embed it into your existing code base, and it will run seamlessly in your existing APK. It works for both iOS and Android. I'm an Android developer, so the only thing what I can say about iOS is that I saw working examples of it. How it works roughly is that on iOS, you can link it together with Cocoa pods or embed the framework into Xcode. And since Flutter version 1.12, the app-to-app approach has become pretty solid. If someone tried it before that version, it was a bit more difficult, but since version 1.12, they have really nice plugin structure and also great embedding, which makes your life quite easy. There are two ways to add a Flutter module into your app. It is creating the module inside your existing code base and link it together. This is also the thing that I want to show you when I'm going into more detail. The other way is create a separate repository and then build it an AAR and then integrate it into your existing app. What it is doing is you need to run a Flutter build command, build AAR. It will build a kind of Maven repository. And what you need to do then is you need to make sure that the Maven repository is uploaded somewhere in, for example, an Artifactory or a location that makes sense to you where you can easily access it. And what you then do is integrate it into your Gradle build. If you run the command, they also provide really nice output how to do it. It's quite simple. I decided to create an example app, comfort food app. I am really big fan of pizzas and burgers, so I was really happy to make a nice app for that. And actually, I explained a bit about the structure. So what you see on the left is the launch screen where you can select two restaurants. And you can, in the middle, you see a pizza screen where you can decide, okay, which size it is, and it will change the price. And that pizza is a separate Android module in my app. And also, the third screen is an order overview. So once you select, the burger or the pizza you want, you press OK. And then you can decide to complete the order, and then you get a nice overview with the total price. Also on the right, you see my new module, which is the burger module, and this is 100% built in Flutter. Okay, first of all, what do we need? Well, of course, we need the Flutter SDK, and the Flutter SDK can be downloaded from the Flutter website. You probably guessed that. Of course, we need our beloved Android Studio, and we need to make sure that we install the Flutter plugin, which is available from the marketplace of Android Studio. And then what we also need is an existing Android project that actually builds. Then, because we installed the Flutter module, it will provide, we can say in Android Studio, new module and then Flutter module. And then it provides us a really nice wizard, which is quite convenient. We fill in some details. And what it then does, it will provide some kind of structure, what you actually can see here. I want to highlight some parts of the structure out. First of all, this is the .android folder, which is generated, and it contains a lot of bindings. And for example, it will make sure that it can find the Flutter SDK. It consists of references to some Gradle files, which make sure that you can build your app and that your Flutter module is properly bundled. The next thing is the lib and the test folder, which consists of your source code plus your unit tests and widget tests. And what is very important is the pubspec YAML file. And the pubspec YAML file contains, you declare there your dependencies. And also what you can do is define some metadata. And what is very important, for example, is the name and the version of it. After generating, what it does more is also it creates a reference to a Flutter project. And this is very important for the embedding because this specific project will do a lot of magic under the hood, especially when we are building the app. For example, what it is doing is it will make sure based on the ABI that you have, so the processors that you support, it will make sure that it grabs the correct Flutter engine. And what it also will do is it will grab the dependencies from embedding. So when you start using the Flutter engine or the Flutter activity, which I will talk about later, you don't need to add those dependencies to your Gradle file, but it's already there by this project. Another reference, what you see on the right, and this is actually the embedding itself, it will link the module and it will refer to the include flutter.groovy, and that one starts a chain of events actually. Because of this approach, it also means that there's a limitation that you can only embed one Flutter module per app. But of course, there's quite a lot of flexibility where you can add multiple screens, and I will talk about that a bit later. Next, what we need to do is, of course, we need to write the application code. I'm not going to talk a lot about Dart code, but you can see here I created the screen containing of some text views. I created a nice checkbox, some image, and of course, some calculation that updates the price when we add fries to our burger. And when we click on OK, what it actually is doing, it will close the app and it will return back to Android. Also, what is quite convenient is that you can run the Flutter app independently on the phone. And that helps in the beginning because you probably don't want to start with embedding until you know for sure it actually works. So what you need to do is you need to run the main.dart file. Okay, then, of course, we have some screen that we can integrate. And what we need to do next is actually integrate the Flutter activity. I chose to use a Flutter activity for the embedding, but there are also other ways to embed Flutter. For example, you can embed it through a fragment and through a Flutter view. What the Flutter activity is actually the easiest way to integrate and embed Flutter because it provides us, it does a lot of work for us, and also it handles a lot of lifecycle events. Also, what you can do, for example, in a Flutter activity is display a splash screen. You can also define a different Dart file to run, the entry point, or you can choose a different route. And routes are in Flutter ways of navigating through the app. So if you want to start a separate part of the app, you can use a route for that. And also, when you start embedding, you can say, okay, I want to run Flutter and execute this specific route. What I already mentioned, if you're a big fan of the one activity approach, you can use the Flutter fragment, but you need to be aware that you need to forward a couple of calls. And for example, a couple of calls that you need to forward is on post resume and on back pressed, and a couple of more. So yeah, Flutter activity is much easier in that regard. And actually, then the only thing what we need to do is I have a card. What I say, okay, I have a Flutter activity, I create a default intent, and I will start it. And then I want to give a demo. So let's see how it looks. So I have my app, and I press on the burgers, and it starts, but I will do it again, because probably what you already noticed is when I tap Mike's Burgers, you see a black screen for around 2 seconds. And as you can see, before it actually loads. So now we go back. So it's awesome, but it is, for user experience, it's not really fast because yeah, it feels a bit slow, right? Let me explain a bit to you what happened. So when we created the default intent in the Flutter activity, what the activity does for us, it will create a new Flutter engine for us. It will create GNI bindings. It will also initialize our app that we created, and it will execute the default route that we have. And as you can imagine, that takes a couple of seconds before everything is wired up. And that's also what you saw. If only we could make it faster. Well, you probably guessed it, we definitely can, because the Flutter team introduced the concept of a warmed up Flutter engine. And I think it makes sense to speed it up and warm this engine up. First of all, what we need to do is we need to create an ID for it. And that ID is not for the engine itself, but it's for the cache, so it can be found. Because later we need to ask to the cache, okay, give us a specific Flutter engine. Then, of course, we create the Flutter engine. And I want to talk a bit about what the Flutter engine is. Because a Flutter engine, you can see it as a kind of a container through which you can run Flutter code and Dart code into your Android application. And what you also see in the second line is the second line below the creating of the Flutter engine, you will actually do the warm up. Because if you just create the Flutter engine, it doesn't do anything yet. But if you say to the Dart executor of the Flutter engine, execute a certain Dart entry point, then it will actually start warming up. This also means that it will start consuming memory, and you need to pay the resources that it will cost to wire it up. Last but not least, what we need to do, of course, is we need to put it in the engine cache, and that's quite simple. It's a singleton that we can retrieve, and we just say to the instance, okay, we add it here with the corresponding ID. So this is what we had before, and this is what we have now. So what we are doing is we say to the Flutter activity, instead of creating a default intent, we now say use a cached engine from the cache. And then, of course, we build an intent and we start it. So let's see how that looks. I press now micro burgers. And as you can see, it is really fast at this moment. I will do it again to be sure. And as you can see, it is instantly. So this is pretty awesome, because now we have the user experience that we want. The screen is wired up nicely. The only thing what we now need to do is, of course, make sure that the data is there. Some attention points by using the warmed up engine, because of course it comes with a price that we need to be aware of. When you pre-warm the Dart code, it means that it begins executing immediately. So it also means that it starts with memory, consuming memory, and also executing the code that you defined in your entry point. Also, what you need to make sure of is that when you want to free up the resources, you call Flutter engine.destroy, because it outlives your Flutter activity or Flutter fragment. Of course, what I said is there are performance implications, and I saw on the Flutter website they have put some numbers. It was based on version 1.10. We are now at 1.17, so they are a bit outdated, but it gives you at least some indication. You need to think of that wiring up a Flutter engine costs 42 MB memory, and also when you start warming up, there is a blocking call to the UI thread of 330 milliseconds. So that's important to notice. Also, what you need to do is you need to make sure that when you start warming up, you choose already the correct Dart entry point and also the correct Flutter route. You cannot change it afterwards. And last but not least, if the Flutter activity is the first activity that you want to show on startup, warming up doesn't really make sense, because you need to wait for everything to start at the beginning. The last thing that we need to do is, of course, sending the data. And what we need to use for that is meta channels. And what are those? So you can see it as indeed a name channel that sends data between the Flutter client and the native host. That's the approach I used for this embedding, but you can also do it the other way around. So Flutter can also be the host, and native can be the client. Messages and responses are always passed asynchronously. You can make sure that from the host that you provide the correct callback, so the client can handle on either the error or the success that you have. And this is very important for Android users, because when you start using Flutter, you want actually to execute some background processing. For example, Bluetooth or databases, you need to execute that natively. And of course, if you do that, the work there is handled on a background thread. But if you want to give a callback towards Flutter again, you need to make sure that you invoke that callback on the main thread of Android. The same counts when you are using streams and you want to send data. You need to make sure that it's provided also on the main thread there. A bit of architecture overview that will give you some explanation about my implementation. First, of course, I want to invoke a method complete order from the Flutter client, and I provide some arguments. At some point, Android starts processing it, checking some things, and it will provide me a success. How does it look on the Flutter side? What we need to do? First, we need to create the method channel. And the name that we create is important because this one needs to match also on the Android side. Then, of course, what I did is I created a kind of simple backend. I invoke a method called complete order. Also, the string name of the method needs to match on the Android side. And I provided some arguments. And as you can see, the arguments are a list of dynamic. And that is because I'm using the standard codec for Flutter. And what that one is doing, before it will actually send it towards native, it will convert it to binary for me. So yeah, that's why I can do this. Also, there's another standard codec that is provided, and that is a JSON codec. But there are also other codecs available as third party. And for example, for my Bluetooth library, I'm using protobuf protocol, which provides us a bit more type safety. Okay, so we have everything on the Dart side, and now we need to go back to the Android side. And what we need to do first is create the method channel as well with the same name. And now it's actually quite convenient that I added the Flutter engine in my application because I can easily access it through application context. And what we need to provide, if we create a method channel, we need to provide the nice binary messenger of the Flutter engine. And of course, the matching name that is the same on Flutter. Then what we need to do is we need to set a method call handler because we are the host and we need to handle the requests that we get from the Flutter client. So let's look how that sees. We created an order method call handler and we override from the embedding the method call handler. And that means also we are forced to override on method call. And what you can see here is I first check the method name. If it is invoked with the correct complete order string, then I will do some things. But if not, I will say, okay, this method is not implemented. And so we can handle on the Flutter side the issue. Furthermore, of course, what you see here is also the arguments are a list of any. And we need to make sure that the types are correctly. And if they are correctly, we can do the processing. And we report the success to Flutter. And if not, we report some error that the incorrect values are supplied. Let's see now the result. How does it look like? I tap on Mike's Burgers. Well, let's add some fries as well. I press OK. You see a button below appearing, which is a good sign already. And if I press it, what you can see here is I get the ultimate burger with fries for $10. So this is really awesome. We completed everything what we wanted to do now. But I can imagine I went through it in 20 minutes. So I think it's very good to wrap things up what we did. So first of all, we created the Flutter module using the Flutter plugin that we installed on Android Studio and because of that, it wired up nicely and it generates a lot of things so we can actually embed the module. Then, of course, we created the code, and what happens is we could launch the Flutter module when we clicked on the card for Mike's Burgers. Then what we did is, because we weren't happy of the user experience, we used a warmed up Flutter engine. And last but not least, we were able to send the data so we can provide a nice overview of the order. Some attention points in regards to the add-to-app approach, because there are some things you need to be aware of. First of all, Flutter does not support 32 bits and MIPS processors. So if you want to start with embedding Flutter, you need to make sure that you deprecate those processor architectures. And also, even more important, you need to set the correct ABI filters in your Gradle file. Because if you don't do it, and you still have so people that have a 32 bits phone, for example, can still install your app. And then it will crash because the Flutter engine for that processor architecture cannot be found. So that's quite nasty. Also, what I read on the documentation is that Flutter in background mode is not fully supported. Already I saw they are doing quite some work on it, but it's still work in progress, so use it at your own risk. Yeah, what I already mentioned before is you cannot embed multiple Flutter modules into one application. Of course, what you can do is you can use different Dart entry points. And also what you can do is you can play around nicely with routes. If you define your navigation correctly in Flutter, you can say from the embedding, okay, in this case, I want to execute this specific part of my app, and a bit later, I want to execute that specific part of my app. Also in Flutter, it can happen that you are using some Android plugins and that those Android plugins are not using the latest plugin structure. What you will see is when you compile your app, it will give you a warning that, hey, keep in mind the Flutter plugin X that you're using is using old Android plugin structure. So really, make sure that you migrate it, because else we cannot guarantee it behaves nicely. Also, and this is quite a no-brainer, you need specific CI for Flutter because the ecosystem is totally different, a different language. Also, what is very important is that from version 1.17, and this is the latest stable, that you need to make sure that your application is migrated to Android X. This is a very interesting one because both Flutter and Android, they are using the material design library, which is Google's UI library. And what can happen is that if there are some new components in the material library, it can happen that they are present on Android, but not in Flutter, or the other way around. So if you want to use those components, always make sure that they are available in both, because you ideally would like to have the same UX experience on both sides. Also, what they say, we saw a really nice trick like warm up the Flutter engine, but of course you cannot do that unlimitedly. Actually, what they are saying, the Flutter team is saying, if you want to use multiple Flutter engines, you can do it. We won't limit it, but it is at your own risk. And the last point that I want to address is that you need to make sure, for example, if you use Crashlytics in your Flutter module and you use also Crashlytics in your Android, what can happen is that, for example, in Android, you use a newer version of Crashlytics than is available in the Flutter plugin. Of course, what Gradle is doing normally, it resolves the versions, and it will install the newest one. But of course, if there are in the API some breaking changes, your Flutter implementation will not work. So in that case, you need to make sure that both Crashlytics on Flutter as in Android are of the same version. Some useful resources that I want to share with you. The basic example that I showed you is available on GitHub, so feel free to look into it. I'm also planning to add some more complicated scenarios for that to give a bit more overview. Also, really check out the Flutter website. They have really good documentation about add to app, also for iOS. And if you are an Android developer and you want to get started, they have a nice starting point. That is the third bullet point. And last but not least, platform channels. I just scratched the surface on it with the meta channel, but they are really powerful. So check them out. And then I want to thank you for your attention. I really enjoyed speaking with you about Android embedding, and I'm looking forward to answer any questions that you have. Thank you very much.
Thanks so much, Rémon. It was really fantastic. Appreciate all the tips and the resources as well. We do have a few questions, so we'll make Uli the moderator, and he'll be able to show you what questions have come up on Slido. So it's all you.
Perfect.
So you should see the screen right now, and you can feel free to read the top question and.
Okay. Can I use Flutter to share business logic code, view models, service calls between platforms? Yeah, of course you can. I mean, what you can do, for example, is if you have some business logic that resides on Android and you want to use it, you can create a meta channel, what I showed you already, and you can execute that function that is on the Android side, and you can make sure that the data is provided into your Flutter application. What is also really nice is actually the platform channels, and I use that a lot for my Bluetooth library because most of the time we have reactive applications, and what you can do there is actually you can provide the platform channel, and that opens a stream between native and Flutter, and then you can react on events from the Flutter side, for example. So this is actually really nice. I hope I answered the question. Next one. Are there any benefits of adding Flutter modules to your app if you only have an Android app and don't need the multi-platform? Oh, that's a really good question. So actually, what I really like about Flutter is if you really have an application that needs to have consistent design on both iOS and Android. And we all know if you were in that situation that it's quite complicated because natively both platforms implement some things a bit differently. So if that is a big requirement from the business, then indeed it makes really sense to start using Flutter. But indeed, if you don't have a need for multi-platform, then the only reason that I can say, okay, it's fun to work with Flutter and learn something new. Are there any negative impacts on performance when using Flutter instead of developing natively? Well, of course, if you run the Flutter engine, what I already talked about is it will consume some memory, right? So you need to make sure that the 30 or 42 MBs are available. But in UI experience, Flutter is really fast. Actually, they are doing a really good job. I saw some benchmarks and what I saw between React, Flutter, and native. And native was just a bit faster, but also I saw already some cases that Flutter is even faster. So they were quite comparable. React Native is still a bit slower in that regard. Okay. Would you use Flutter or Kotlin native if you only want to share business logic? Yeah, that's a really good question as well. It really depends on what you really like. Because if you have a lot of experience with Kotlin native, then it indeed makes really sense to go for that one. But of course, if you also think, well, maybe we have a need to build some screens, and we want to move more to a more consistent design on both platforms, then yeah, go for Flutter. Okay. If you use a Flutter activity and you navigate within Flutter code to some screens, will things like Android backpress work like expected? Yes, I can actually show that. Yeah, so what it will do is actually it starts an activity. So if you do a backpress, it will also close the activity. But of course, what you need to keep in mind is if you have a pre-warmed engine, it don't destroy the engine. So in that case, you need to make sure that when you come back to that specific activity, that you also destroy the engine. Of course, if you don't need it anymore. Okay. What is the benefit of using multiple Flutter engines if you can only use one Flutter plugin in your app? Or do you use one engine per entry point? So if you use a warmed up engine, you already need to make sure that you define the correct entry point up forehand. So if you have two different Dart entry points, then of course you need to use multiple warmed up Flutter engines. But you can also decide to not use a warmed up Flutter engine. What you can do is, for example, if you have a previous activity and you know, okay, next activity, I may need a Flutter embedding, you can already make sure in that previous activity, you start a Flutter engine and you warm it up. And then in the next activity, when the user presses it, it will have already a nice warmed up engine. And then when you are a bit further in the app, you can say, okay, at some point I destroy it, and you can also create in a different activity a new engine. How would you test the integration? That's a good one, because what I normally would do is make sure that both modules are tested separately already, and then I would go for example for a very lightweight test, maybe 2 or 3 scenarios, just to check that it is working, and then I would maybe consider tools like Appium for it. Okay. With each Flutter bound to a single Flutter route. Is it possible to test the Flutter UI using Appium? Yes, because it builds just an APK, and you can test it for sure. And then with each Flutter engine bound to a single Flutter route, what's the best practice to implement lots of unconnected screens in Flutter within a native app? So what you can do in that case is what I taught you before. You have at some point you have some activity and you need a specific Flutter round a bit later. So what I would do then is make sure that you warm up an engine with that specific route, and also close it to free up the resources, and then make sure that in some other parts in your app that you warm up an engine with a different route and then start using that one. What are your thoughts about mixing native and Flutter in a large code base with lots of engineers/moving parts? My thoughts is actually if you make if you just discuss it with each other and you have good ground rules about how to do it, and you have a nice modularized app, in my opinion, that's really a thing that you need to do. Then I think it can really work. So if you most in large code bases, mostly teams are responsible for a couple of modules. And yeah, if you have a good separation in that regard, I don't see any issue to do that. And then last one, that's or Flutter or Jetpack Compose. For me, that's 100% Flutter. And to turn the situation around, have you seen a Flutter app use Kotlin multi-platform for business logic? Ooh, that's really interesting. I didn't see it, but probably there is one because the app community is quite creative. So if you see one, send it to me. I'm quite curious. Okay, thank you.